Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3301 Data Structures. The unit is list. In this video, we are going to discuss about linked list implementation, singly linked list. At first, we are going to discuss about what is the difference between array and linked list. Array means it stores its nodes in a consecutive memory locations, and comparing with the array, the linked list does not store its nodes in a consecutive memory location. In this array, the array allows random access data, but in the linked list does not allow the random access of data. Nodes in a linked list can be accessed in only the sequential manner. In the array, it cannot add any number of elements in the array, but in the linked list, it can add any number of elements in the list. Singly linked list. A singly linked list is a simplest type of linked list in which every node contains some data and a pointer to the next node of the same data type by saying that the node contains a pointer to the next node, that the node store the address of the next node in the sequence. A singly linked list allows a traverse of data in only in one way. This is a structure of singly linked list. At first the start node, then after that this is a 1 2 3 4 5 7 elements are there, and then each node contains the two parts. First one is a data part, then second one is a pointer part. Then traversing a linked list, accessing the nodes of the list in order it to perform some processing on them. A linked list always contains a pointer variable start which stores the address of the first node of the list. End of the list, it is marked by storing the null value. It is marked as X, that means null. In the next field of the last node. For traversing a linked list, we can also make use of another pointer variable which points to the node that is currently being accessed. This is the algorithm for traversing a linked list. First step is initialize, that means set pointer. First pointer equal to start. Then that start contains the pointer for the first node. Then second step is the repeat steps 3 and 4. That means apply process pointer to data. Then set pointer equal to pointer to next. That means each node contains two fields. First one is the data, after one is the pointer field. In that pointer field, that points to the next data. Okay, then after that the loop becomes, in this step 4 we can move to the next code by making the pointer variable point to the node whose address is stored in the next field. Then next one is the algorithm to print the number of nodes in the linked list. At first we can traverse each and every node of the list. While traversing every individual node, we will increment the value by counter. Initially the counter value is 0. After that we can start, then repeat these steps. That means the set counter value to, that means the counter value will increment by one value. Once we reach null, then that means when all the nodes of the linked list have been traversed, the final value of the counter will be displayed. Then searching for a value in a linked list. Searching a linked list means finding whether a given value is present in the information part of the node or not. If it is present, the algorithm returns the address of the particular node that contains the value. In this step 1, we can initialize the pointer variable pointer with start that contains the address of the first node. In this step 2, a while loop is executed which will compare every node data with value for which the search is being made. If the search is successful, that is value has been found, then the address of the particular node is stored in the pointer POS, that means pointed to the location, then and the control jump to the last statement of the algorithm. However, if the search is unsuccessful, then PO is set to null, which indicates the value is not present in the particular linked list. The next one is inserting a new node in the linked list. How a new node is added to the linked list can take we will take 4 cases. First one is in case 1, the new node is inserted at the beginning. In the case 2, the new node is inserted at the end. In the case 4, case 3, the new node is inserted after a given node. Then the case 4 is the new node is inserted before a given node. The next one is the important definition of the inserting linked list: overflow. That means overflow is a condition that occurs when available equal to null or no free memory cell is present in the system. When this condition occurs, the program must give an appropriate message. At first, we are going to see about case 1. This is the case 1. Inserting a node at the beginning of a linked list. Add a node with data 9 and add it to the first node of the linked list. This is the procedure. At first, initially the start location, then after allocate the memory for the new node and initialize its data part by to 9. Okay, add the new node as the first node of the list by making the next part of the new node contain the address of the start. So now we'll make the start to point to the first node to the list. This is a representation of inserting a new node at the beginning of a linked list. The next one is inserting a new node at the end of the list. Here the add a new node data, that means 9 toward the last of the list. At first allocate memory for the new node and initialize its data part to 9 and next part to null. Then take a pointer variable pointer which points to the starts. After that move pointer so that it points to the last node of the list and add the new node after the node pointed by the pointer. This is done by storing the address of the new node in the next part of the pointer. The next one is a case 3, inserting the node after a given node in the linked list. That means the new node 9 is inserted after the node containing the data. For this same the allocate memory for 9. Then after that take 2 pointer variable, pointer and pre-pointer. Initialize them with the start so that the start pointer come next pre-pointer to the first node. Then after that move the pointer and pre-pointer until the data part of the pre-pointer equal to value of the data. After it inserted come to done, then pre-part of the pointer will always point to the node just before the pointer. And after that add the new node in the between the nodes pointed by the pre-pointer and pointer. Then next case is inserting a node before a given node in the linked list. Same as for the after the linked list. Here we have to insert the pre-pointer and same the pre-pointer and also the start node. Then deleting a node from the linked list. Here also there are 3 cases. First in the first case the first node is deleted. Then in the second case that last node is deleted. Then third case the node after a given node is deleted. In this deletion operation underflow can occur. So underflow is a condition that occurs when we are trying to delete a node from a linked list that is empty. This happens when start equal to null or when there are no more address to delete. Note that when we delete a node from a linked list, we actually have to free the memory occupied that the node. The memory is returned to the free pool so that it can be used to store other programs and data. Whatever be the case of deletion, we always change the avail pointer so that it points to the address of address that has been recently vacated. Thank you.